Let's look at this. What is your name? What is your cost? What is your favorite color?
What is your favorite color?
Have you taken calculus before? Yeah, I took it in high school. I got a C, by the way, the first time I took calc, so this was a 2. This was a 2 run for me, so if you get through in 1, you're better than I am. Most people get through in 1. I'm kidding with you. Not about the fact that I had to take it twice. All right, so this creative function thing, let's go through it. All right, so here's how I did this. Your, of course, methodology may vary, but let me go ahead and show you what I did. We'll get rid of this. So I do the first ones that are obvious, right? F of 0 equals 1. That's that point there. F of negative 4 equals negative 2. That's that point there. F is defined everywhere. I'm going to leave that for a minute. Let's just leave this for a moment. And then this condition. For every x greater than 0, f of x equals negative 2. So what is f of 1? Well, yeah, so 1 is greater than 0. Therefore, f of 1 is 1. F of 2 is, of course, 1. F of pi is, I'm sorry, not 1, negative 2. F of pi is negative 2. Anything greater than 1. So that means that f of 0.00001 is negative 2. Anything greater than 0. So what I'm going to do is I'm going to draw an open circle there, and I'm going to run this off to infinity. And now I've got another, so that takes care of that condition. And then I've got this f of f is increasing on an interval. Okay. So I'm stuck with these 2 points up here. And since I'm stuck with those 2 points, here I got to be below, right? Because I want increasing. And here I need to be below because I want increasing. So now I'm just going to kind of connect the dots. La, 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 la. Oops. That's fine. I don't know why I'm bothering being so perfect. And what I might do, because this is a condition here, I might go from negative 6 to 0 and just kind of note for myself that it needs to be increasing this direction. That line looks bad. Okay. And now, so now when I come back, I've got this other condition that I haven't met. I want it to be defined everywhere. Where it's defined over here, it's defined over here. I just need to make it defined for the rest of them. So anything less than negative 6, I'm just going to draw an arrow that way. It doesn't matter where I draw the arrow. If I wanted to be creative, I could do something like this. That's fine. I can make it go like this. That would be fine. It's just it has to go off to infinity. Okay. And I know the interval of the increase because it goes from negative 6. That's told me. F of x is increasing on this interval. That means when x is between negative 6 and 0, f of x is going up. So y goes up. And that's what that means. Yeah, the exact slope of the line does not matter. All that matters is that it's increasing. All right. So how do we feel about, oops. I hate the poll system here. Hold on. Which question was this to? So how do we feel about that 1 to 5? Oh, and then I'm going to check the vertical line test, right? Because I need to check my vertical line test. So I'm going to go across here and make sure I didn't do any doubles. So I just run my ruler across and make sure I didn't do any vertical line test violations. Yep. So it doesn't include that 0, even though it doesn't have to include this 0. So I could have technically made this happen. This thing would have worked too. Right? I could have had it extend until it reached 0 and then jump back down to 0 and then jumped here instead of drawing this line here. So there are other things that I could have done. There was no condition that said it couldn't be increasing at 0 as well. So I just made it increasing at 0. All right. If you're uncomfortable with this, there is a review packet on Canvas. Let's see. So if you go to, how do I do this again? Here we go. OBS will be on top then with all the stream information. I don't want that. Okay. Okay. All right. So let's go back to the thing. Let's go to the next one here. Okay. So all the problems on this page refer to this function here. So this function's a nice little piecewise function. If we drew it, if we drew this function, what would it look like here? Kind of like this. And you kind of have a point there at 0. Okay. So here we've got kind of the answers to this thing. this is what it looks like. Now, f of 1, well, if I plug in 1 for x, I use this rule here, correct? So I get 1 over 1, that's 1. Whereas for f of 0, it's 4. So, and then f of 1 over 100, well, that's 1 over 1 over 100, which is 1 divided by 1/100th. 1 over 100, which is the same thing as 100, right? I flip it over when I multiply by the reciprocal when I divide the fraction, and I wind up with 100. How do we feel about those three parts there? 1 to 5. Share, polling. Of course, you're asking questions now, and I can't see it because I am, so 3, A, B, C. And of course, I can't see your questions because start. There we go. So those first three parts, just subbing in for these things, doing the little bit of multiplication. All right. Feel pretty good about this. Now, for this part D, here, I said that t did not equal 0. So which rule am I using? Well, I'm using the rule 1 over x. So I take t, I sub it in here, and I just get f of t equals 1 over t. Now the domain. What is the domain of this second rule if we only look at the rule? It would be every number but 0, correct? And then, but I do have an assignment for 0, right? This is not undefined at 0. This is perfectly well defined at 0, correct? If x equals 0, f of x is 4. If f of x is not 0, then f of x is 1 over x, but that's fine. That's defined everywhere but 0. So what's the domain here? Well, it's everything. All real numbers. I could write this as this cute little r thing. Or I could write this as negative infinity to infinity. So how do we feel about that? 3, 4. I need a macro for this, don't I? This is question 3, part E. There we go. Well, it's not really a limit. So for part D, it's not really a limit that we're looking for because a limit is a number. And what we really want is this expression 1 over t. Okay. So these first questions, A, B, C, D, and E, are all supposed to be pre-calc review. This one you've actually seen before, this F, but you've never seen it in these words. So the intimidating thing about part F is that these are new words. Image. Okay. Well, the intention of the question was for you to go on Google here and try to figure out that what it was talking about was something you actually saw in pre-calc. Okay. So for this stuff, here, this idea from pre-calc, the idea was that what you're going to do And I'm sorry, this is taking me longer than it should to figure. So the question I want to ask, if x was in the set 0, 1, where would y be? So how do we feel now about what that question is actually asking? Oh, nope. What is this? F? So how do we feel? Not about how to find out what it is, but just what the question is. The question is, what is the range if I restrict the inputs to 0, this interval, 0, 1? Okay. So if I restrict my inputs, if I restrict my domain to A, what's the range? And there's a couple ways to figure that out. Okay. But the easiest way is graphically. So what I'm going to do, I can do this a couple of ways. This window here. I can actually draw this image by doing, okay, here's the x space from 0 off to infinity, right? And I'm going to restrict it from 0, not including 0, to 1. Well, if I do that, then 1 maps to 1. 1/2 maps where? If x is 1/2, y equals 2. If x is 1/4, y equals 4. If x equals 1/1000, y equals 1000. So as I go along here, well, if x is 1/2, I go here. If x is 1/4, I go here. And all of the shaded region here is going to map to all of the shaded region here. So my answer is 1 to infinity as an interval, including 1, obviously excluding infinity. All right. How do we feel about that? Did I just figure out how to do this? Yes. Okay. All right, so the question is, can I do another example? Yeah, let's look at another example here. Let's say f of x equals x squared, a equals 1 to 2. What is f of a? Right, what is the image of a? Well, let's see. Where is 1 going to map to? Does it look really blurry? It shouldn't, but it could because of the downsampling that oh, that I can actually fix. Is that better? Okay, perfect. Okay, so I want A to be from 1 to 2. So if A is 1 to 2, that's this area here, from 1 to 2. Well, what is f of 1? 1. All right, what is f of 1.5? Oops. What is f of 2? Yeah, it's 4. And this function is increasing monotonically, right? It's going if I make this part bigger, I make this part bigger, correct? It's only going one direction. It's always increasing. There's no point where I go, oh, we're going to go down here, right? Because I'm starting at 1. I don't have 0 involved here, but it's just that's minimal. So that means here, what's going on here is I'm going to sweep out this as my image. Everything between 1 and 4, including the imports, is going to be hit. Right? Those are all of the y's I'm going to reach. So that means here that f of a equals 1, 4. And it doesn't always have to be the endpoints, right? Here, the endpoints got flipped. Here, the endpoints are not flipped. If I ask the same question, let's do c equals same function f. If I did c equals negative 2 to 0, what would f of c be? Okay, where's negative 2 going to go? Right, negative 2 is going to go up here to 4. Where is negative 1 going to go? Positive 1, exactly. Where is 0 going to go? Exactly. So here, all of the movement is flipped, but the numbers here map to the numbers here. Oops, that included more than just that. I didn't want to do that. There we go. All right, how do we feel about that? 1 to 5. So, oops, let me do another one. Oops, I didn't mean to close it because every time you close it, Wait a minute. It was supposed to ask, and it didn't. Update. Oh, bugger. Yeah. Okay, so now it should be showing, right? The poll should now be active. Okay. You may have to click in the lower right-hand corner. I just found that. So that means that here that f of c equals this red area 0 to 4. Okay. Later in calculus, what we're going to do is we're going to actually use this to find things like images. Because one of the questions we're going to have is this. What happens if D equals -2 to 2? And we're going to ask ourselves questions like, what is f of D? So what is the image of this? And it's not going to be as simple as just picking off the endpoints anymore, is it? Because this right here is 4. So -2 maps to 4, and 2 maps to 4. But is it the case that everything is stuck between... Is it the case that the image is just the number 4? Well, no, because you've got stuff in the middle that maps down here to various places, right? If I have -1, where do I map? And if I have 1, where do I map? Same place, right? And if I have 0, I'm going to map here. So my image here is not just determined by the endpoints, but the stuff in the middle. So my image here is actually 0 to 4. Even though f of neither of those two is 0. And that's actually going to be, we're going to be able to use calculus to solve for these minimums and maximums. So one of the questions we're going to have, yes, all of these f of x was x squared. So this question actually relates to something we're going to do in Module 3, because what I'm going to want to do is I'm going to want to solve for this minimum and these maximums so that I can actually find the images of continuous functions. Okay? All right. Let's go on. Okay, now I'm asking you to find this difference quotient. And this is a pre-calc review thing. But I'm not asking you to simplify. So what I'm going to do is I'm just go f of x plus h minus f of x over h. Well, f of x plus h, since nothing is 0, f of x plus h is 1 over x plus h. And f of x is 1 over x. So f of x plus h minus f of x is simply 1 over x plus h minus 1 over x over h. How do we feel about that one, 1 to 5? All right. So this was this difference quotient thing you saw at the end of pre-calc, where you found the slopes of secant lines and stuff like that. And why do I care? Well, where we're going in Module 1, the reason I care is that because the definition of the derivative is a limit of a difference quotient. So I'll write this out so it looks nice. So this is the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. And this right here is the whole point of Module 1. So everything we're doing up to the first test is going to be, well, not everything, because we're also going to do limits at infinity and stuff like that. But the whole point of the first module is to get to the definition of the derivative. Okay? What logged me out again? And if you look on the syllabus, heaven forbid, if you actually read the syllabus, it tells you that. So, tablets. Nope, that's something I really don't want up. There we go. Right. Okay, and by the way, this right here, how did I know what F was? Well, because I told you up here. F is this thing up here at the very top. Remember, all problems on this page refer to that F. That's always a point of confusion. So now, if you wanted to simplify it, you could. There's the work. You wind up with -1 over x plus h times x. You could simplify that further. -1 over x squared plus x times h. On Wednesday, during the quiz review, which of course you don't have to attend because you're attending this one. But if you, on Wednesday, I will go over exactly when to simplify, when to not, and how to kind of judge that. Are there any other questions?